Welcome back to Cara 4. I'm Cara and I'm currently building a Cyberdeck based on a broken MacBook Air M1, 2008 Apple keyboard and a touchscreen. On the first episode we tore everything down and now we're getting into the meat of it. Let's go. I'm gonna try to reassemble the MacBook with only the screws for the cowlicks and see if the main parts work, like the main board press ports, then add the battery, test it again, and then add the TouchID, test it again. Okay. USB-C and USB-C. I'm gonna hold it and plug it in. Now the power supply connected. We have a computer! TouchID needs to be connected to this, which has a long cable. They're so small, so cute. Let's see if you have TouchID. This time I'm gonna use a USB hub. This is synchronizing. So maybe USB PB in. And this. Let's go back to direct testing. Yes. So if I connect this back to the hub and the hub back here, no signal. Maybe the display is not detected in the same way. Let's reboot it. And now the hub is powered. The display says no signal. I'm gonna have to configure it. It's now working in this form with the keyboard and touch and display always working. I'm gonna move to the next step, which is TouchID, see if the trackpad works without the PCB, and microphone. It's so tiny, it's so sticky. I just taped it using Kapton tape and protected the cable. It should be enough, at least for now. I'm gonna remove the heat spreader. It's nerve-wracking, but kinda necessary. Oops, spinnered it. According to my research, it's not a vapor chamber, it's just a piece of copper, and it kinda looks like it. So I'm gonna carefully pry it open. Solid amount of thermal paste. Removing some thermal mass is not a good idea. I could also cut this. Magnificent. It's stable, it's 47, but it's very hot here. I'm gonna try out the fan that I plan to add inside. 45, 43. Yeah, I'm just gonna add a PID loop on this and it should do the job. Okay, let's make a case and refine it. I'm gonna make just the footprint of the base and then build up from there. Add screw holes that will allow us to have a few points. This is end of day one. I iterated a lot on the motherboard and on the USB hub. I came up with this. There's just lots in there. Okay, I need to cut a bit over there. Okay, this is a bit snug. I can force it in. There's space for one insert here and it seems to be bang on. I'm gonna mark it. And there, two inserts. And there's a standoff here. The final feature is a blower fan that I'm gonna control according to temperature. And it just slots in here. The USB-C hub. Where is this? This has been cut. The keyboard. Lastly, power. And now it should work on this. And yeah, there you go. Touch works. And the temperature is okay. This is so cool. This is my progress of 2 days of work. This should work because it's gonna coil around and connect there with a bracket. It will be constrained for sure, but it should just work. If needed, I can add more space here. Con depth is 17 millimeters. Also, I have so much extra space here. We'll see with the battery, but maybe Meshtastic. I'm so excited! I didn't film an update in a few days, so here's what I'm being up to. I changed the LCD controller position to there, so I have enough space for the rearranged battery here. It will be on its own tray and protected from both sides, at least during work. Here I noticed that I have 1 extra centimeter, so I'm gonna move all of this like this. I'm gonna add 1 more centimeter to this gap so that the cable is a little less bent all over the place when it's crushed. And this cooling solution is not ideal. It's just too many interface materials. So I'm gonna replace just this, add 1 bigger heatsink like this that is 100 by 70 centimeters. I'm just gonna have to cut the corner so that it fits. But it's gonna give me a lot more thermal mass. I noticed while testing that the MacBook was actually throttled because there was no battery. So the thermals were not actually as good as I wanted. So I hope this just solves it. Plus this type of heatsink, because that's the same type I will get, is copper instead of aluminium. That's a plus. And has these small dividing squares that I can just use as a guide to cut very cleanly and then file it so that it just like cuts on the corner and stuff. And as a bonus, it's gonna put something inside this hole that I have nothing to place in, because I decided to add the Meshtastic, but it's gonna be there because I'm gonna have a display. To add the bongo card or something, or extra notification from the system. Could be good to have like mail notification from my phone or something. I don't know yet. The scope of the project is increasing every day, but yeah. New iteration. I'm gonna add all the inserts and test it out live because I feel like this is a major version. First step is the 2.5 millimeter ones. I try to keep them in the base as minimal as possible since they're gonna be in resin in the end. And I don't want any heat there, so most of the real work is happening on the tray. New side quest is the speakers, because the speakers that are connected to the LCD are very bad. At least keep one for like basic sound and put it in mono in the system. This one is perfectly placed. Maybe I could just cut around this line. Yeah, I'm a butcher. And then reseal it and still have better sound. Yes. I have my new heatsink, 130 grams. And the one it replaced is just 14. So that's gonna give me some extra thermal mass. And in theory, I can just slot it here and cut some of it off. Our heatsink. Wonderful. I'm gonna take care of this USB keyboard situation. It's not a very good soldering job, but it's in there. And I have a keyboard. How amazing is that? I made a tray for the battery, The cover is currently printing. This goes over here, and then the cable should just reach. And there you go. I have a Cyberdeck. This is a unit. If printing large parts in resin causes you despair just like this, or you want to upgrade to SLS or CNC parts, need some PCBs manufactured, you definitely will want to check out today's sponsor, PCBWay, who decided to provide a CNC shell for this project that you're gonna see in part 3. PCBWay is a one-stop manufacturing shop for PCBs, including rigid flex and assembly, 3D printing, including metal, CNC machining, sheet metal fabrication, and injection molding. Go to their website and simply use the auto code. PCBs start at $5 for 10 pieces. Please tell them I sent you by using the affiliate link below. Now back to itty-bitty buttons. I have spent the entire day on this, probably made like 15 versions. Initially, TouchID was attached on the same tray as the motherboard, and it kind of makes sense because they're on the same plane and because it fits. But the problem is that TouchID itself is working, but the clicking component, aka the power button, didn't always work. I was until then relying on screwing the 4 tiny screws that are on the bottom, just barely, so that I can adjust the point where the touch button touches but doesn't press. Here we're gonna replace it by a M2 by 8 screw that we're gonna thread from the bottom. We're gonna have just enough space to adjust here the point where it meets. The 4 screws will be attached to this part. When we press the button, it's gonna flex ever slightly, and this flex should be just enough to press the button. That means that the button also is now rocking instead of being straight down, but I don't think we're gonna notice, especially if I adjust it correctly. I'm gonna free the connector and tape it. You can see the 4 screw holes and how the button itself is recessed. And now we should be able to take the 4 screws and drive them through there. The 4 screws are in. Logical answer. I added the spring and now it clicks. So in theory we have a mock-up now. We can press the button and it works. It freaking works. I want to cut this along this line so that I can move this over there. I got the fire blanket, so it's fiberglass and a lipo bag. So if something goes wrong, I will just wrap everything in the blanket and go downstairs on the concrete. I will unlock my door and put on my shoes. Battery, scissors, spudgers. The easy part will be to cut this. Okay, it's not that easy. Nice. Kapton tape is not enough. Let's use some electrical tape. Second side. And this is good. On the edge, on the back. And now really protect it. My instinct will be to take a blade and trim it, but no. Yeah, the other side is barely holding together. Now this cable is just stuck in place with barely any glue. Like this one, it was very easy glue. So I'm gonna try to lift it up, slice the glue. We have been liberated. And now I need to cut this. I feel like all the metal edges are really dangerous. Let's try to use plastic picks and just unglue this one battery. If it's difficult but not too difficult, I can then cut afterwards. So careful. Oh my god, there are ripples on the battery. I don't want to know why. I'm gonna try to cut this now, okay? I'm scared. I'm not just pretending, okay? Good enough. I'm just gonna add a lot of tape. This should not puncture. I will do the same on the other side. We have a battery. So it used to be like this. I'm just gonna say don't do what I'm doing. This is totally reckless. Nobody actually needs to do this. Okay, that was very stressful. I think I got it. This looks safe. I'm done doing dumb shit. Yeah, look at that. And of course, this cable can reach there. You probably noticed that I have a gaping hole here. My original plan was to use a ESP32, probably the ESP32C3. Add the joystick as an additional mouse input, a scroll wheel. This is an encoder from an actual mouse, and also control the fan using this thermistor that I have for my very first 3D printer. I also want to use these capacitive buttons. Apparently they work through plastic, but while working on all of that, I decided that maybe I could use a Meshtastic node. This is the Heltec T14. This one really sips power. I got the full-fledged version with GPS and the LCD. I'm very familiar with Arduino and it would have been very easy, but since I'm gonna modify the firmware, it's gonna be a little more difficult. I'm ashamed of it, but I'm gonna use Cloud. Everything fits very tightly. Now I just have to print everything and make sure it actually works in the real world. But I'm confident. One step forward. All the pins of the microcontroller are now used, and I still have Meshtastic. Yes! I also decided to change this screen for e-ink display. The e-ink display is bigger, will not consume anything, and it's gonna be more useful for like stats or I don't really know, to be honest. I rewire everything. I added reset switch here. Everything is kinda neat. It's maybe not compact enough. I have way too much wire here, and this is gonna go there. So I'm gonna have to optimize somehow. If I really don't manage to fit it here, I can always go back to this option and prolong the GPS wires. So that's why for now it's this length. I really don't know. But it should fit, I mean. Yeah, maybe I added too many zip ties. I spent a few days refining this plate to mount the trackpad on the back of the Cyberdeck so that I can control it like this. I figured out a new solution for the trackpad, and it's basically organizing this cable around there. It's gonna be stupid, but it's gonna work. And I'm also printing a brace that will connect on these points and hold this into place. The test fit version of the bottom shelves I finished printing. Yeah, I'm kind of excited to see how it looks like. Since I'm gonna move to aluminium, this gonna go because ABS or ASA is an insulator, and we want as much thermal transfer as possible with aluminium shell, and it's supposed to really not necessary anymore. And now, in theory, this should just go on top of this. Yeah, oh my god. I've been waiting so long for this. Can you imagine? Been working so hard on this, and just coming to life here. Oh my god. Of course, aluminium is not gonna flex. Shout out to PCBWay who decided to believe in this project. There it goes. Oh my god. I have a Cyberdeck. Oh my god. I can't believe it. Everything is so tightly packed. Oh my god. These holes are for the microphone and this is for the speaker, because it's about there. Wow, it's so good. I'm now ready to order the CNC shell from PCBWay, and I'm gonna show you how to do it. First, I used to have parts spliced like this. I consolidated all the quadrants together, so now we have one piece. Then I decided to optimize it the best I could for CNC. That means no extra feature we really don't need. Save on material wherever I can, and just make sure that the corners, like here, are actually CNCable, because originally we had this, and this is just not possible. Then I added threads in the threaded holes. This is very easy because you can just type S thread and add the threaded hole. Then I used the section analysis tool to make sure that there is no hidden pocket. For example, I remember that here it used to not connect totally to the bottom. Now everything is CNCable. I also made sure that the tolerances are within what they give you. For example, here I have 0.35 millimeter. I know that will be more precise than this, but I want to have just a little bit of wiggle room to be able to align them just in case something is just shifted by 0.15 or something. To CNC things, you need to have step files and not STL, like for 3D printing. STLs are basically triangles, and what we need is a description of every feature. And we need to do it half by half, so I hid everything I didn't need. Currently we have the top shell. Right click here, export, and export as step file. Then I made technical drawings to show them exactly where the features that they don't want to miss are. For example, here the threaded holes, so I know they will not miss one. For example, the small here, or I won't have to thread anything by hand myself. Threading holes is no big deal, but that means I don't have to do it myself. I won't have the horror of having one tool fit on me and break inside a 2.5 threaded hole. Regarding critical tolerances, I decided to point them exactly what needs to be precise. For example, you don't want to have a surprise where the screen doesn't fit inside the hole just because it's slightly off. I added margins, but you never know. So I made sure of that for the screen, the one for the keyboard, TouchID, the trackpad, and then the lip around the corner, because the two lips need to meet here and we have to make sure that the tolerance is enough. And that's why I added a second drawing just to show them exactly how they meet. I think this is probably more than enough because everything is in a step file, but you better be safe. Next step was to go on the PCBWay website, CNC machining, select my file, just select quantity 1, aluminium. This is the regular aluminium that is used for MacBooks. I think MacBooks use the 6065, so it's very close to that kind of quality. I selected my finish. I wanted anodized and bead blasted to have a clean finish. Then I uploaded my technical drawings regarding threaded holes, regarding tolerances. Here we can specify, we can select what type of tolerances we need. In my case it was quite loose, but I specified that the tightest tolerance was 0.15. Surface roughness, okay. Assembly test, and I had the drawings for that. And finish, I wanted premium because standard is just for technical parts and premium is more for finished products that you actually touch with your hands. And that's it. 10-12 business days. That's it. Thank you for sticking to the end of this video. I'm very excited to put everything together in the new shell as soon as it arrives, because this is not cutting it. Stay subscribed to see the end of this project and probably more very soon. I'm very excited about what I'm cooking. And there's work in progress on TikTok and Instagram if you really cannot wait.